Well, hello again, Hacker Stage. How's everybody doing? Woo, we got some excitement. How many people are here are mentally present? Like you're actually listening, paying attention. And okay, now keep your hand up if you also have a laptop. Because this is a workshop in the truest sense of the word, which means that I'm going to be making sure that as many of you as I can have actually walked out of here having built smart contracts that do things on the internet. Okay? So this is a very audacious goal, a little bit different than a lot of the programming, including my workshop yesterday. So really the goal here at the end of the day is if you walk away with smart contracts that compile and execute successfully, then we've been successful. If you're having trouble with your headset, check another headset. All right. As we get in here, my name is Fluin, which you're probably sick of hearing from me at this point, but I am head of developer relations at Axelar. And really, this is one of my favorite things to do is I do a lot of the let's think big, let's get inspired, let's get motivated talks. But this is on the absolute other side of the spectrum where it's like, hey, let's actually build something together, and I'm gonna actually walk you through and give you code to do things. And so we're going to break this into two parts because we had, as you may have seen from Sergey's talk yesterday, we had a surprise announcement about Interchain tokens. And because Interchain NFTs, Interchain tokens are very connected concepts, I'm actually going to do a live demo of how to build an Interchain token. So that video that Sergey was playing yesterday, I'm going to show you all how to do it and give you the actual secret URLs and things like that. So you're on a good stage, you're in a good place. And then we'll go into just general, what is an Interchain NFT? Well, what are we actually building today? And then I'm going to abandon the presentation side of it, and we're just going to get hands on keyboard and actually copy and paste code and move code around so that you actually are building things. So let's start off with Interchain tokens. So how many people saw Sergey's talk about Interchain tokens, where you saw the little video? It's like, oh, you have an ERC20, now it's an ERC20 on every chain that you want. Okay, only one. So this is actually, to me, one of the coolest things that I've seen come out of Axelar since I joined, and I joined a couple months ago. So it's really kind of this magic idea that you can do things that are very hard, right? Wrapped tokens is a difficult concept in general. And so what I'm going to do here is I'm going to do things all from scratch. So we are going to build an ERC20 in about a minute. And again, this part I'm not going to wait for everyone to do, so this is a little bit more on the demo side, and then I'll make sure that everyone's following along with the Interchain NFT side of things. But just, we're going to make it an ERC20, we're going to ship it on a testnet, and then we're going to make it Interchain. So let's go ahead and pop open. Here, I'm going to start with a Google search here. Let's search for Open Zeppelin Wizard. Has anyone who's seen the Open Zeppelin Wizard before? This is a magical UI. I absolutely love this UI, because if you want to create an ERC20, you want to create an ERC 721, they've baked in these standards, they baked in a lot of really cool features into this wizard that gives you a smart contract. And so with this, I now have my ERC20, and then I'm going to open it in Remix, and we'll just jump right over there and see if this works. All right, we're not going to call it my token, we're going to call it, I don't know, Interop token. The ITK. So very official, very simple, very straightforward. And one of the things that I like to do is, actually no, this it automatically includes an initial supply and all that. So we don't have to do anything. This is enough that we can actually ship this on a testnet. Let's choose our testnet very carefully here. And I'm going to just switch to AVAX here. There we go. All right. So instead of just testing it locally, we're actually going to ship this to AVAX, and I'm going to hit the deploy button. That should be going here. Transactions processed, and let's actually go ahead and take a look at our transaction. And then I need to switch to the testnet. We should see my contract. We should see the contract I created. All right, this looks like an ERC20. And now what we're going to do, I'm not going to worry about supply, minting, all that. I'm just going to leave it really, really simple just to start here. I'm going to copy that address, and I'm going to go to the secret URL. Is everyone ready for the secret URL? testnet.services.axelar.dev. So we're on axelar.dev. This is an Axelar developer service. It's a service, and we're on the testnet version. And so what I can do is I'll just paste in my ERC20. And this really works with any ERC20 that exists on the testnet. And we will see this is not registered yet. So I'm going to go ahead and register it with what we call the token linker. So this is this smart contract that exists on every chain. It's identified our token, it's identified the decimals, all those sorts of things. And now I get to choose which chains I want to deploy on. So let's just choose a couple here. So based on the number of chains that you choose, which chains you choose, that's going to cost you gas accordingly, so that you are paying for the gas to execute all of these contract creations across all of these chains. So choose as many as you want to pay for in terms of gas, and then you're going to hit register. It's going to register my origin token. And then it's going to actually handle, it's going to use call contract, this method that comes from Axelar that I talked about yesterday, to actually talk to the token linker on all of the other chains and say, hey, create an identical wrapper around this contract. So it says registered origin token and started deploying remote tokens. All right, so if we go ahead and take a look at this in, we could go into Snowtrace and all that and follow along. Let's, instead of waiting for the network propagation, I'm just going to pause that and we can come back to that later if people are interested. But effectively, we can now see you've got Avalanche. I can send tokens across chain. Obviously, that ERC20 has minting capabilities. And then as soon as that propagation across the network has happened, you'll see all of those chains pop up here. And if you wanted to deploy that wrap token on any other chains, you can do that here. And so effectively what you've done is you have now a method that exists on the token linker contract where you can send tokens from any chain to any chain that you've registered your token on. That's kind of cool. Building the challenge 2 in the speedrunning that we didn't get to yesterday was build a wrap token, which I think might have taken another 2 hours. So this, if they had known about this, it probably wouldn't have taken 2 hours. It would have taken them about 2 minutes. Questions? Any questions about the interchain token? Because literally that's it. We've now built an interchain token. Okay, seeing thumbs up, and I'm going to move on then. All right, back to the meat of today. So I called this workshop building an Interchain NFT. Now, does anybody have any ideas of what an Interchain NFT might be? A contract that gets deployed on multiple networks. Yes, that is 100% true. Any other properties that we might think about them? Ah, see, exactly. So he said you burn on one chain or you mint on another chain so that you only have this NFT on one chain. And that is the way that most people think about NFTs. They think about moving an NFT from one chain to another. But I'm actually proposing a different definition here. And one of the fun things about NFTs is that NFTs are 100% built around social consensus. NFTs only mean to you what you think they mean to you, right? If you think an NFT represents a mortgage, if the US government believes that an NFT represents a mortgage, then it represents a mortgage. If they don't think it does, then it doesn't. And so NFTs can really be whatever you want. And so what I want to build today is actually an NFT that lives simultaneously on multiple chains. So imagine an NFT where instead of being able to exclusively live on one chain, it simultaneously lives on a bunch of chains. And then when you make changes to one of those NFTs, when something happens to that NFT, those changes propagate to the other chains. That sounds kind of cool. Like there's a lot of really interesting things you can do there. I mean, there's problems with this as well, but imagine if you could list that NFT on multiple exchanges, and then as soon as it sells in one exchange, you propagate that to the others. Or you integrate with some other cool dynamic capabilities. And then as soon as that NFT updates, as soon as something fundamentally changes within that NFT, that propagates to all the other changes, all the other chains. So I think that's a really cool mental model for NFTs. That I think the industry needs to explore a little bit more. And so that's what we're actually going to build today. And now there's lots of different ways of having an NFT live on multiple different chains. So the simplest and the one that we're going to be taking a look at today is what I'm calling pairs. So we'll choose 2 chains and we'll make each of the chains or the NFTs on each of those chains aware of the other one, so that whenever anything happens to the first chain, it'll happen on the second chain and vice versa, right? It's synchronous. There's no leader, follower, master, slave. It's just 2 chains, equal NFTs. Whenever something happens to one, it happens to the other one. Some of the other models you could consider would be hub and spoke. So do choose a base chain for your NFT just to handle the communication. Also, you could do it fully decentralized. So the original version of this workshop that I actually built had it fully decentralized, where there was a registry on every NFT, and all you had to do was attach a new chain NFT to that registry, and then it would parcel out, hey, I'm going to go let every chain that has this NFT know about the new chain, and then I'm going to go let the new chain know about all the legacy chains. The problem with that is Testnet ETH is hard to get a hold of, and those are very, very expensive, like handshake problems, right? If you wanted this on 7 different chains, what is that? It's like 7 factorial to like number of messages you have to send. And so the fully decentralized model, while I think it's kind of sexy, it's very cool, it's very expensive. And I don't think it's necessarily appropriate for the world today until we get gas costs under control in a different way. So the prerequisite. So I said this is going to be like hands-on keyboard type of exercise. Hopefully you already have Node.js, so you can use 16 or 18. Hopefully you have Git, so you can clone the code. Theoretically, you could download a zip bundle from GitHub if you want as well. And you need an IDE. You don't need VS Code, but that's what I'm going to be demoing and showing everything off with. All right. Good so far? Thumbs up? All right. I want everyone to be able to access these slides because I'm going to be looking at a lot of code in the slides, and I'm going to be copying and pasting so that I don't fat finger something. So you have the exact same code that I'm going to be running as well. And so if you go to this URL, and I'll do this alongside with you, what you'll notice is that it opens a preview of the slides. And what you need to do is there's this secret little bar at the bottom, which controls which slide you're on. Click on the 3 dots, and you're going to say Open in Editor. That doesn't work for some reason. Okay, if that doesn't work, you can go. What's that? Oh, more, and then open editor. Thank you. See, this is the type of collaboration we need. This is perfect. So if you open an editor, then you're not going to be able to edit everything, but you're going to be able to copy and paste things. So you say, like, hey, I really like this word that you just used, copy it, paste it. You'll be able to interact with all of the code that we're going to be building here today. But I'm going to be building it alongside with you, and then we're going to have 3 checkpoints where we actually pause, and we make sure things work on my computer, and we'll make sure things that work on your computer for following along as well. All right. So let's keep going here. So I have the slides here. If you missed it, you're going to probably want these slides. Like, you can just follow along with everything I do, but it's going to be much harder to manually type all these things and potentially get something wrong, especially when we're doing, in the beginning, we're merging some smart contracts, which is kind of an interesting idea. So we're going to go through this in 6 relatively simple steps. We'll do some setup. We'll make sure that we've got an ERC 721. We'll make that ERC 721 configurable so you can change the token URL. And then we'll deploy 3 different functions that exist on this NFT. One for connecting 2 of these NFTs, so letting them know where the source chain, destination chain is. One for updating the NFT, so we'll just change the URL of that NFT. And then we'll update the execute function. Or we'll create an execute function that actually receives those messages across chain. All right, so we're going to dive in now. Let's biddle. So the setup. Basically, what I'm going to be doing here is I'm going to be using the Axelar examples repo as a base for everything we do. So Axelar examples is a fantastic repository that all of the code examples in it are already set up with hard hat. They're already set up with like shared keys, things like that. And so what will happen is Axelar examples will actually give you the ability to run all of these different local blockchains. And so when you run git clone, this repo, and you run npm CI, which hopefully doesn't take too long. I think on bad Wi-Fi earlier today, it took about a minute. So if it's taking much longer than that, let me know. But I've actually already done these steps. I'm going to keep this in presentation mode. All right. I've already done these steps over here. And so what you should see when you run this is you'll clone the repo. It'll copy all the objects down by git. Then you'll run npm CI, which will go and fetch all the npm dependencies. And then it will actually do the build. So we'll do a first initial smart contract build. It'll run setup. This setup command is something that I actually built into the repo to automatically create a private key for you. So in general, I want my testing repositories to not have a real key that actually has like real assets on the blockchain. But if you did want that, that's absolutely something you can do. You just change the .env file. So we've actually given you the mnemonic and the private key in your .env file. We just randomly created one for you. If you have one already and you just put it in the .env file, it will not create that for you. And then we ran npm run start. And what npm run start does is it spins up local Ganache instances of 5 different blockchains. So Moonbeam, Avalanche, Phantom, Ethereum, Polygon. We're not going to use all these today. We're just going to be using 2 chains, but it doesn't matter to have them running in the background in Ganache. And then when it's done is it's deployed all of the Axelar services on top of it. So it has the gateways, which you need to send messages. It has the gas services, which you need to use to pay for those messages. All right, so back to the code here. So have we been able to clone this repo and run npm CI? No. Too slow. So that is it the git part or the npm part? You're stuck on git clone. Is anybody else stuck on git clone? Okay. That npm CI we can kind of like work around because we can start working on the smart contracts. Git clone is harder. If only there was a decentralized version of Git that would use like a mesh network. Does anyone have that working today? No? Okay. Well, we'll keep waiting for that. Maybe Interop next year we'll have decentralized mesh Git and we'll just all clone from each other. Like BitTorrent, right? Okay. Has anyone been successful in cloning the repo? Okay, good. All right, so after you've installed the dependencies that are there, these are just, right now we just have a stock Axelar examples repository, but we're gonna go ahead and install OpenZeppelin contracts. So OpenZeppelin puts out these fantastic ERC, as we saw with the wizard, they just have all these contracts and these interfaces that are very, very easy to use. And so what I'm gonna do is I'm gonna go here, and I'm gonna npm install at OpenZeppelin contracts. That was pretty easy. So now basically my smart contracts, now in any of my Solidity code, I can import these things that our wizard is gonna tell us to do. All right, next, what I'm gonna do is I'm gonna copy one of the example repos. And here, what I'll do is I'll actually show off just a little bit how Axelar examples is laid out. So in the Axelar examples repo, you're gonna see a lot of like boilerplate, like here's the hard hat configuration, here's the prettier configuration, ESLint, all those sorts of things. The meat of everything that you're gonna need to touch today is in one of these folders in examples/EVM. And what you're gonna see is each of these is a pre-built example showing off different ways of using Axelar. So you've got call contract, which is really like, hey, let's pass a simple message. Like, let's just pass a string. You've got call contract with token, which is let's pass an array of strings and a token. You've got the GMP Express, which Kate demoed a little bit yesterday. You've got cross-chain lending, cross-chain tokens, NFT auction house, NFT linkers, sending and receiving. So sending and acknowledging a message. So this one's kind of cool because it like you pay for both sides of the transaction, assuming that you're gonna hit a destination contract and it's gonna call you back. And you can pay for it all from the source chain, which is kind of cool because otherwise you have to figure out how do I get the assets on the destination chain. So all these things are really, really helpful examples. And what we're gonna do is we're just gonna go ahead and copy the call contract example. So we're gonna copy the simplest example that exists. So I'm just using just terminal commands. You could theoretically do this in a GUI, but I'm just copying recursively the examples EVM call contract folder, and I'm calling it Interchain NFT. And so what we'll see here in our IDE, let's see if we can make this a little bit bigger, is now we have this Interchain NFT. But there's a problem with this, which is that everything still says call contract, right? The folder name that's hard-coded, all those sorts of things, they all still say call contract. And so the next step that we're gonna be following here is updating it just to be our own project. So theoretically, you can use the names that I'm giving you. You could also come up with whatever names you want. But I'm gonna rename the file from executable sample to Interchain NFT, just so that we know what we're working on here. So we're gonna rename this file. And then I'm gonna find and replace executable example. So I'm gonna find and replace executable sample with Interchain NFT. I'm gonna do that both in our Solidity code. So this is just the sample Solidity code from call contract, and in the index.js that's responsible for deploying. All right, so that is done. There's one more rename that we need to do, which is just in one place, which is the folder name is no longer call contract. It's now Interchain-NFT if you followed the commands that I've been recommending here. And so you're gonna find that right up at the root require, where instead of finding our Interchain Sol in call contract, we're gonna find that in Interchain NFT. So again, this is all vanity. If you wanted to skip this step entirely and just leave all the old names, you could, although it'd be a little bit wonky. And then if you're thinking long-term, you should probably update your own README to remind yourself what you did, how you did it, talk about what you're doing. READMEs are a really good idea because one of the big problems that developers run into is that they don't realize 6 months after you've written some piece of code, you are not the same developer. And you're going to look at that code and you're going to be like, what was this person thinking? So always try and update your READMEs. All right, so the next one is probably the most complicated step of actual coding that we're going to be going through. And so let's take a look at what we actually have today. If we look at our Solidity file, we have an Axelar executable. So this is the interface that lets you send messages. So we're going to call contract, which sends messages, and it's going to execute, which receives messages. So all of that is via the magic of this Axelar executable interface. But we actually want something more complicated. We want a smart contract that is both an Axelar executable and an ERC-721. So we actually have an NFT that will show up on OpenSea if we want it. And so what we're going to do is we're going to jump over to the wizard again. And this time, and you don't have, like I've copied and pasted the code in the slides for you, so you don't have to necessarily do this. But I just want to show you the process. So you're going to say ERC-721, come up with whatever name you want, Interop NFT. NFT. And then the one thing that we want is we want auto-incremented IDs so that we can mint these whenever we need, and then it gets the next ID in the sequence. So first it'll start with 0, then 1, and I don't have to be worrying about keeping track of that and then doing this myself. And so here we have an ERC-721. That's great. We could ship this and put it on OpenSea right now. But we want both. We want to combine an ERC-721 with an Axelar executable. And so there's a few steps that we're going to follow to actually do that. And so all of those steps are written in the next slide here. So basically what we're doing is, if you know smart contracts, if you know Solidity really well, this should be really straightforward for you. But I'm going to add the imports to the bottom. I'm going to fix the inheritance. I'm going to add the counter variable as well as the using so that we get the right properties on it. And then I'm going to add the ERC-721 constructor, and I'm going to use the SafeMint method. So I'm going to do this step by step here. So we need these imports so that we actually can execute the same code. I apologize about this. There we go. It's a little bit better. All right, so we need our imports, so we're just going to paste those at the top. Next up, we need our is statement. So because now the smart contract that we're building is an Axelar executable, but it's also an ERC-721 and an ownable. And coming along with that interface, we're going to be using counters. So I'll just paste that here at the top. And then we're going to fix our constructor. So this is a syntax that you may not see very often, but you can actually, like, when you have this multiple inheritance pattern, you can just pass multiple of the super constructors here. So we've got an Axelar executable constructor passing in the gateway, and then we've got the ERC-721. All right, so now we're constructing it properly. Let's see what other code here. I think the last thing we need is the SafeMint function. So this just gives us a function that is going to be minting in that sequential order that we talked about. And so I'll put that right under the constructor. All right, and at that point, we've actually now merged our Axelar executable with an ERC-721. So I'm going to give you folks a minute, or like 30 seconds to a minute, and then we'll move on to the next step. And then if anyone has questions while folks are catching up and following on.
What is the gas service?
The gas service. So when you want to make a Interchain contract call, you're actually executing code on 3 blockchains. The source chain, the Axelar network to get consensus on the transaction, and on the destination chain, because someone has to actually execute the contract call on the destination chain. And so you're actually using 3 different types of gas, and you can go figure out how to do that yourself if you want, or we created this Axelar gas service where basically you pay in the native token of the source chain, and we will pay for all of those stages. So we have a couple other methods, but I would highly recommend you pay in the native token just because it's much simpler. Oh, the question was, can you pay in another ERC20 token? We have some other methods. I think you might have to pay in like destination chain token, like native token, like the wrapped version of the native token on the destination chain? I'm not sure. I highly recommend you just use the native chain. But it's a great question. If you wanted to know the answer to a question like that, what we would do is we would jump over here. We go to docs.axelar.dev, and we would take a look in the developer section, and you would look for the gas service. And so you're going to learn all about that gas receiver, how it works, because there's certain cases. For example, imagine the gas price on the destination chain spikes, right? Like if it's 1,000x, we're not going to be able to cover that transaction with your original gas. And so there are methods where you can add more gas to a contract for, like you can pay more to a transaction to allow it to complete and things like that. And so all of this walks through that. And then, so you can see here, you've got like, you can actually pass in, pay this gas token versus native token. So there's a few different options. Pay gas for contract call with, All right. Have we been successful at merging our Axelar executable and our ERC 721? I need to see at least 3 thumbs ups. We've got 1. Okay, where are people getting stuck, or how can I help? It's the internet. Are we still waiting for Git?
No, but like,
you're behind. Okay. Well, let me. NPM CI is running slow. I used to think that NPM CI was only for continuous integration environments. I was totally wrong. That's a poorly named method. It's NPM CI. All it does is it installs from your package lock file instead of from your package JSON. That blew my mind when I found that out. Because I looked at all these code samples and I'm like, that's wrong. We're not in a CI environment. But it is faster to do NPM CI than NPM install. All right, so I am gonna keep moving. I apologize. Did we get at least 2 thumbs up or just 1? All right, I think we got 2. Perfect. All right, so we have now merged. We use these 5 steps. We've merged our ERC 721 into our Axelar executable. And next up, we are going to just do one little helper thing, which is I'm going to mint an NFT as part of the constructor. So this is just going to be like for demoing, example purposes. This just makes it really easy that we just have an NFT and we don't have to go through an extra step with everything I do of actually minting that NFT. So I'm just going to say, hey, every contract or every chain that you deploy this contract to, just mint one NFT. And that would be token ID 0 for those of you that are counting. That step's pretty easy here. All right, we're going to go on to the next step here, which is actually a checkpoint, because I should now, because we have all that set infrastructure that came from called contract, we have this contract that should be working and should compile. I should be able to actually run a build. So this build does the hard hat compile of my Solidity. That could expose errors if I've typoed, if I'm missing a comma in any of my constructors, any of my parameters. That'll do the build. And then we're going to do 2 things. We're going to do deploy. And so this deployment puts that smart contract on the blockchains that we're actually interacting with. And then we're doing an execute method to do this, to actually invoke one of the commands. And so because we left in the call contract command that it's expecting set remote value, which we'll get rid of in a second, this should still work, and it should actually just work identically to call contract if we've done everything right. So I'm going to go ahead, paste that in. It's doing the hard hat compile. And as you can see, we've now deployed all those that NFT contract to all these blockchains locally, and it's actually executed. And we see, if we take a look here, the call contract code still works. So it had a value that was blank on Phantom at the beginning, and at the end, Avalanche initiated a contract call all the way to Phantom with that message. So we've been successful. Our smart contract compiled. It's an ERC 721, but we're not taking advantage of that yet. All right, so we actually had time built in here. So if anyone can use this time to catch up at all, that would be fantastic. Or is there anything I can do to help? Because again, the goal here is to have you walk away with working code on your laptops. And if you don't have that, I've failed. So I'm actually going to walk around and peek. So if you don't want me to peek, just let me know. So I think what we've learned here today is that the hardest part of building smart contracts is GitHub and NPM CI. NPM and GitHub are the problem. All right, we're doing great on time. So, but I am gonna keep moving. So, do we still have at least one thumbs up? We got 2 thumbs up. 3. What's that? You will give me a thumbs up by the end of the day. I like that. That's a promise. I'm gonna hold you to that, Eric. All right, let's go back to our slides here. All right, we've merged the example and we've hit our checkpoint and our smart contract. If we merge them correctly, it still works, which is a really good place to be in software engineering, is your code still works. Now we're gonna start getting into actually the next steps of modifying these examples for our specific use cases. And so the first thing I'm gonna do is I'm gonna create a new local property called token URIs. And what this is basically gonna allow me to do is it's gonna allow me within my ERC 721 to specify a different URL. So part of the spec for an ERC 721 is that there's a URL that it's correlated with. And so this will make it dynamic so that I can actually change it over time if I want to. So I'll just add it to the list of properties here. So it's a mapping from a token ID to a string. The string is going to be a URL, the token ID, or the uint is a token ID. And the second half here is I'm going to set my token URI to this JSON that I have pre-prepared. And this JSON has a little bit of a silly story behind it. So let's take a look briefly at what this token URI is. So every token URI is a JSON blob that looks like this. And so what this is this is a NFT that can over time, it's a Stephen Fluin NFT that over time levels up. And so if you look here, it starts with little Stephen wearing my DNA is life, the rest is just details t-shirt. And then as you change the URL, if you guys go from 0 to 1 to 2, etc., there's me when I used to wear suits every day to work at a software engineering company, to working at Google and giving presentations in China, having some kids, and then moving back to Minnesota. So that is the Stephen journey that this NFT could go on if you want to here. And we'll just take part of that journey together. All right, so what we've done is we've basically initialized, every time we mint a new token, we're gonna initialize it with that little baby Stephen. Maybe in the future I should go back to like actual baby pictures. All right, and now the second half of this is we have this token URIs, but that's just a property right now. That's not actually part of the spec. And so what we're gonna do is we're gonna implement this override of the token URI function that's what everyone's gonna see. So when it's a public view virtual override. And so what we can do is we'll give it an implementation that tells it, that tells the world to look at that string, that property that we created. Very cool tip, if you hit the command palette, format document. I love format document. I don't ever format any of my code, and you shouldn't either. It should just format on save, or just run format document over and over and over. It's human beings that format code, you're just causing problems for everybody. All right. So we've got a token UI. So now if you ship this ERC 721, not only would it be a valid ERC 721, but if you registered in OpenSea, you'd get a little Stephen picture, which is great. All right, so in a normal call contract, we're only, or in the call contract example, we're only making one interchain call between source chain and destination a single time. But because in this example, we're actually going to be doing it a couple times, I'm having us take the code that we exist right now called set remote value, and I'm refactoring it into just a helper method called send. And so we can be sneaky here. We can just copy all of that. And what we'll do is this will allow us to just call our send method because we'll already know the remote chain and the remote address whenever we're sending. Does that make sense? So normally in the call contract, you need to specify that every time. But what we're going to do is we're actually going to save that as a local variable, which I believe is actually the next step. So in the call contract example, what we do is we save the source chain and the source address, which it's not that helpful. That's only helpful if you're writing code from the context of a destination address. So what we're going to do is we're going to change this to remote chain and remote address. Because if you remember, what we're trying to do here is that we're trying to have our NFT be aware of its pairing, its compatriot on another blockchain. Okay? So now we have a place to store that, and whenever we call our send method, our helper method that's going to initiate this interchain contract call, we're using that chain and address, so we'll always be talking between these pairs of NFTs. All right. Next up, we get into the real meat of things. So this is where we're going to actually start connecting our NFTs. And so there's a connect NFT function, which looks a lot like our send NFT function. So we're actually going to go ahead and just replace it. So instead of this set remote value, we're just going to paste connect NFTs. And so what you're going to see here is this is the place where we create our NFT, and now we're going to tell it about, hey, this NFT actually exists on another chain. And so we're going to give it the destination chain that its friend has, and we're going to give it the address, and it's going to save those, because now forevermore, it's going to be linked to other NFTs, so any other further interactions you have with this NFT, it's going to be sent to the other chain. And then we're going to do this magic payload. So I'm encoding the number 1. So this is a trick that I use in order to do complex things. And so if you look back at the call contract code that we started with, the payload was like the string that we wanted to send. But what I'm actually going to be sending different payloads depending on what method I'm doing. When I'm connecting to a different chain, when I'm connecting my NFT to another chain, I need different parameters than when I'm updating the URI of it. And so what we do is we can just always encode the method that we want to invoke as that first parameter, and then later you'll see where that we're switching based on that, where we have an if statement. We're conditioning on that. And that's really it. All we do is we're going to take that destination chain that we want to connect to, and we're going to say, hey, method 1, which is connect. And we'll implement that in a second. The next thing that we're going to be doing interchain here is an update function. So this is where we're actually now propagating not just a connection between blockchains, but we're actually propagating a property change. And so this is the function that you would want to call if you want to change the URI of a token. And so just like you would normal on a single chain NFT, you're going to take in the URI that you want it to be and a token. So obviously, because we implemented this token URI method, we could just take in a uint and replace part of the URL. We can replace the whole URL, whatever is appropriate for our needs. With this example, we can do that. But we're going to take in that new URI and token on the destination or on the source chain. And I've got a cool little thing here, which is, what if I didn't connect my NFT to another NFT yet? What if I just deployed it and I started wanting to interact with it? I can actually just detect that, and we'll say, yep, we updated the local NFT. There's no remote paired NFT, so we're not gonna do anything. We're just gonna return. So this is handles an edge case where, like, if you haven't actually connected, you just have a single chain version of this NFT, it'll still work, right? We will still do the updates that the user is asking for. But then, if we pass this conditional and we don't return, then we're going to encode a new payload. And that payload, we're going to use that trick that I mentioned. So we just come up with a new method name or method number. So this is method number 2. And then I'm passing along those same properties. So the new URI and the new token. So we're encoding that into a bytes, and we're passing that bytes as a payload. And that's going to get delivered all the way to the other string via that same send method. And do you want me to go through the send method a little bit more? There was a great question about gas contracts. So the send method is really simple. So what you're doing is this is a method where you're paying the gas. So first we're checking and we're seeing if the user's transaction actually has the gas necessary to do this. And I'll show you this on the index.js side in a second. But when you call the send method, you're giving it all the gas that it needs to pay for that end-to-end transaction call. And so we're using that gas service. And so basically we're just passing that entire message value off to that contract. And we're saying, hey, here's the which contract is actually initiating the transaction, and where is it going, which determines the fee. Here's the payload, here's the sender, and all of that gives us enough to actually enable the gas receiver to pay for that end-to-end transaction. And then we're calling the gateway and saying, hey, Axelar network, here's a transaction that you actually need to go and execute. So we're doing that when we connect them, because that involves an interchain transaction, and we're doing that when we update them, because that involves an interchain transaction. All right, next up here, we have our execute function. So we already have an execute function down here, which is saving things. We're just going to blow that away. We just need a blank one for now, and then what we're going to do is we're going to implement that switcher that I talked about. And so here is the magic trick to creating a single execute method that can handle a bunch of different incoming contract calls from other chains. And it's that method switcher. And so what I do is even if you have a very complicated payload, you can have as many parameters in your payload as you want, but ABI decode is actually really smart. It can actually just give you the first thing. And so we're asking, hey, what is the first thing? And we'll know that as our method locally. And then we have a switch. We have, hey, if it's connect, or it's connect if it's method 1, if it's method 2, then it's update. And we write our code for each of these. In the if statement, you can have as many methods as you want. You could use enums, you could use like strings. I recommend ints just because they're small, fast, cheap. And now we're gonna just implement our 2 methods, because method 1 is if we received a contract call from Connect NFTs, and method 2 is if we received a contract call with a new URI, new token. So let's go ahead and do both of those. So actually, we're getting into a checkpoint before we do that full thing. So by blowing away our execute method, we made sure that it's going to still work. And now what we're going to do is we're going to go clean up our index.js, because we've built some new methods that we want to actually use. And so let me walk through what we're doing here. So in our first example, there's lots of things in the index.js. This is, again, hard hat JavaScript code that's handling the orchestration of our smart contract. So we're not going to touch the root require. We're not going to touch deploy. When we run npm run execute, that is what is doing, that's what this code is doing. It's pulling in the options, so you can actually specify which chains on the command line you want to be sending from and to. It's got a logger. It's got all these sorts of nice things. And what we're going to do is we're going to jump in right after the calculate bridge fee, and we're going to replace this whole chunk. Oh. So what have we done here? So we're saying initially we'll log the value, which is not super useful right now because it's still printing out those strings. We're defining a sleep method. The sleep method is just a helper, because in this contract environment, or this smart contract environment, there's going to be synchronous transactions, right? Like in JavaScript and hard hat, normally, if you do a local execution of a contract call, it'll be synchronous. You change the value, it'll immediately be the correct value when in the next JavaScript line of code. But we're doing a cross-chain transaction. And so the block is going to be finalized on the source chain, picked up by the Axelar network, and then executed on the destination chain. And so we'll actually want to be waiting for those and checking and seeing if it's ready in order for our little JavaScript orchestrator to work here. And so we've got a sleep method that we're going to use a couple times, and then we're creating a transaction. And all this transaction is doing is it's calling that connect NFT method on our source contract, and we're giving it the destination name and destination contract. And hard hat, again, knows about this because hard hat is the one that deployed all of our smart contracts. So when you run that command that we talked about, this npm run deploy, that is creating new smart contracts on all of the chains. And so it knows the source name, the source or the destination contract, destination chain name, all those sorts of things. All right, so with that, we actually should be able to run this again. So I'm just going to run the exact same command where we're going to build the Solidity. We're going to run or deploy the smart contracts to the blockchain, and we're going to execute our connect method. We're getting some warnings because we got a bunch of variables we haven't used yet. That's totally fine. And it says remote connection created successfully. And so if you get that, that means you didn't make any mistakes in your Solidity code, and our JavaScript still works, and we're actually able to initiate that communication between the source chain and destination chain. All right, I'm gonna give everyone about 2 minutes to catch up to this checkpoint. And we've got about 13 minutes left in the session. So thank you all for sticking with this. We've got this. We're about right on time. All right, do we have any thumbs up for anyone that's been maybe going ahead at all? All right, I'm gonna walk around and help folks. So the question came up of what is the index.js actually supposed to look like when I'm done? And so I'll just pull that up and we'll just leave this here. So we're keeping everything up to calculate bridge fee because basically what we're doing in JavaScript is we're using our knowledge of the source and the destination to figure out what the fee should be, so that then we can pass it into the contract execution, so then that can be passed into the gas service. So we keep that, and then everything from there to up till after is new. So start here, end here. And I'm gonna, maybe for a few of you that have been a little bit behind the whole time, I'm gonna whip out a secret in one of the last slides of the presentation. Because you all have the slides, you can all jump right there, but in slide number 35, there is a full version of this entire project complete on GitHub. And so if you want to just look at exactly the changes that I made, you can look at this commit. You can see everything from, hey, here's the Interchain NFT that we created. Here's the new README I created. Here's the index.js file. So if you want to see the end state and match up to anything like that, that is there in slide 35 of the presentation. All right, and so one more time, we're just putting in where you have a sleep method. As soon as we calculate the bridge fee, we need a sleep method. We're going to create a connect NFTs transaction. We're going to wait for that, and then we're going to say we've created a connection successfully. All right, any thumbs up? Okay, moving on to the next step here, where we're almost done. You all have been amazing. Oh, sorry. So now, we left our execute method, it was blank right now, right? We've got, in our Solidity, we've got this great execute. It's switching based on the method that we're using. Let's actually go and implement that. So the method one is very, very, very simple. Save the chain that sent you the message. Whoever sent you a message, that is now your best friend, and you are BFFs for life. Method two is similarly simple, in that all we need to do is we need to decode the payload into a URI and a token, and then save that URI. So we have to create local variables in order to decode the payload. We need a place to store them. This comma at the beginning just ignores the method. We don't need to set the method again, although we could. And we're going to take the string, the URI that was sent from the originating chain. We're going to take the token ID from the originating chain, and we're going to set it locally. Pretty straightforward, right? Our best friend told us that they updated their URL. We need to update our URL now too. And so we're doing that here. Okay? And that is really it for our Solidity. So our Solidity now has a connect method, an update method, and then the ability to receive both of those methods via an execute. And so all three, both the first two methods here, those initiate cross-chain interchain transactions, and the last method is going to execute based on the payload that's coming in. So the last thing we need to do is we need to actually test this out. Let's go ahead and update our source chain NFT. And so what I'm going to do here is I'm going to just, in our index.js file, after our little end here, I'm going to paste a little bit more code. All this is doing, it should look very similar. We created transaction 1, we're creating transaction 2 now. And we're calling the update method with the new URI and the token address. So I'm just hard coding 0 because we know we created 1 token for this demo. And the Steven NFT is leveling up to level 4. Woohoo! And this time, because I want the UI to actually wait, I'm not just going to wait for the transaction, I'm going to wait for the full interchain resolution. So I'm going to wait for that destination contract to actually equal the new URI. So we could run it here, but there's one more step I want to take to make things a little bit more beautiful, is I have this giant log method. And so we're going to just replace the log method that exists from the call contract. So if you remember, this method existed way back when, just to show what was the string, the source string, and what's the destination string, and then did it change. We're replacing that, and now we're actually going to be logging the source NFT URL, the source NFT connection, the destination NFT URL, the destination NFT connection. So we're going to see all the parts of these NFTs that we created and deployed to the blockchains. And with that, we should actually be at our final checkpoint. So let's go ahead and just run the command again. So again, we're going to build our Solidity, deploy the contracts locally, and execute them. And if we've done this right, we should see first that it deploys it, so it's got no connection. It's got that 0.json. And then we make a connection, so it has that NFT connection to Phantom and to Avalanche, so Phantom and Avalanche know about each other. And then the last stage is resolved, and both of our NFTs have updated to 4.json. And we did it. All right, let's clap here. Success. So if you were able to follow along in those steps and get the smart contract and the index.js updates successful, you now have working code on your machine that you can use for anything, right? This is an example of NFT. I know a lot of people that actually hate NFTs, but you can imagine, what if that wasn't an NFT? What if that was some other contract? What if that was a DEX that needed to be able to communicate in synchronized state between two different chains? What if that was a stablecoin? Like, whatever example that you want to come up with, DeFi, non-DeFi, gaming, whatever, you now have the code that will let you synchronize state between simultaneous contracts on multiple blockchains. And it's relatively simple code, right? If we can build it in an hour, here live on stage with me talking through and explaining everything, you can definitely go home and do it tonight, which Eric is going to do. All right, do we get one final thumbs up, or are we stuck? Oh, we got, okay, thumbs up there, 2 thumbs up. All right, that is awesome. And definitely, if you were not able to complete this, if NPM CI was just like punching you in the face throughout this entire session, you're like, Steven, why? Why did you make me use NPM? I couldn't use PNPM or Yarn or something faster. I apologize. We'll definitely be around. You can always reach out to me on Twitter. You can come find me at the event. Happy to help. Happy to make sure that, you're feeling supported. So we did it. If you want to just jump directly to the completed example, it should look very similar to this example here. I mean, obviously we were kind of coding on the fly here, so there might be just different white spaces, different method names, things like that. But this is an example that works. You can just check that out. It's in the main branch. One of the cool things you can do with this is, if you remember in our little command that we're running here, we're telling it to run on local. What happens if I wanted to run it on a testnet? So what I'm going to do is I'm actually going to copy over an env file that I have with actually has tokens in it. Axelar examples.finished. So I'm going to copy over an env file that actually has some testnet tokens. And so what I should be able to do now is call this method, instead of locally, we're going to really deploy this on real blockchains. So obviously this is going to go much slower. This is going to use real testnet currency on both Avalanche and Phantom. But the magic here, and it will take a lot longer for the cross-chain communication to resolve, one of the magic pieces here is it's actually going to show us every time we make a cross-chain call, it's going to show us that GMP call, and we'll be able to look it up and actually watch it on the Axelar network. So all right, we've got our contracts deployed to Avalanche and Phantom for real. They've got no connection yet. I can tell in the background it's creating that GMP express call, or that GMP call. And what we can do here is we can actually go look at this on real blockchains. So this is that general messaging passing or general message passing call that we created between the source chain and the destination to create that initial connection. And so we can see, oh, it started on Avalanche, it went to Phantom, it made the contract call, the gas was paid correctly, consensus is being created by the Axelar network, and so you can actually see and debug this whole interchain journey that your message passing is taking. And then what will happen here is this will actually just sit and wait for that to finish before it goes on to the next step. But in just a few moments, we should actually see a completed demo. And the real magic is if we can take one of these contract addresses that we created, like our Avalanche contract. So this is a real thing. So if we go to Snowtrace again, we should see our NFT. There's the Interop NFT. And even better, if you go to OpenSea, or the testnets.opensea, testnets.opensea. Thanks, Google. And we paste this contract in, we will actually see our NFT. You will see it's on Avalanche Fuji, there's our collection, and there's the original picture. So as that URL gets updated on both those chains, you can actually ask OpenSea, it's very, very slow and sometimes flaky. You can ask it to refresh the metadata, which will recall that getTokenURI method, and it will change. So we were able to deploy a change to my contract on both the chains, and they're automatically going to be kept in sync in both directions. So bidirectional syncing. All right, I'm not going to sit here and wait for consensus, because that could take forever. Although we have 3 more minutes, but I'm just going to kind of finish up the slides, and then we'll do one final check. So if you want to try this with your own, like actually want to do this on Testnet, just change the word local to Testnet. But one of the things that we started talking today about was what is an NFT? What is an Interchain NFT? We have different ideas. These things mean different things. So you need to figure out what the use case that you have is. Two examples that I would actually point you to that use Axelar as well, in that Axelar examples repo that you have on your machine, would be our NFT linker, which is a more traditional, like let's mint it here, let's burn it here. And then there's also an NFT auction house where imagine you could buy an NFT from a different chain. So like, let's just handle the auctioning of an NFT in an interchain manner. So those are two examples that are relevant, but trying to solve a different part of the stack. And so that's going to be it for me. My name is Stephen Fluin. Feedback is absolutely welcome. I would love to hear what you thought of this workshop. I would love to make it better in the future for all of you. Obviously, we got a couple folks. I think we also have swag. So everyone who hung out and stuck it through an hour of this workshop where we're actually live coding and I keep poking you and asking you to do things on your computer, thank you for hanging out. And we've got Axelar swag for everyone.